Alright, let's now go through the second half of our review for the final. We are going to start off with graphing an ellipse. You can tell that it's an ellipse because we have different numbers in front of the x squared and y squared terms. So even after we divide by the 225, we will have an a squared and b squared that are not the same. So our first step will be dividing everything by the 225. And when we do that, let's go ahead and write that down. We're going to have this, and then the y squared term, and then of course over here 225 over 225, because we want to make that part of 1. So in this case we'll end up with x squared over 25 plus y squared over 9 equals 1. And now we have the equation in the form that we want for an ellipse. Our center is 0, 0, because neither one of these have parentheses. So it's centered at the origin. And in this case, a is 5, a is underneath the x squared term, and b is 3. b is underneath the y squared term. So now our vertices will be 5, 0, and negative 5, 0. Those are the endpoints of the major axis. On the other hand, our endpoints of the minor axis, that's the shorter one, well, those will be 0, 3, and 0, negative 3. And so this gives us 4 points to start off our graph with. So first off, it is centered here at the origin, and then we're going to go 5 to the right and 5 to the left. So that's our major axis. And then we're going to go 3 up and 3 down. And those would represent the endpoints of the minor axis. Now, just as we did for a circle, we need to get 4 more points for a total of 8 to do this graph. And again, we want to pick something that is approximately halfway between the middle and an endpoint of the major axis. So let's try that x equals 3. And so that will give us 9 over 25 plus y squared over 9 equals 1. So subtracting the 9 over 25 from both sides, we'll now have y squared over 9 equals 16 over 25. And then multiplying both sides by the 9, we end up with y squared equals 144 over 25. So that leads to y equals plus or minus 12 over 5, which again we're going to graph, so we'll do decimals, plus or minus 2.4. So since we used x equals 3, we have 3 2.4 and 3 negative 2.4. Now, as mentioned before with the circle, since this worked for x equals 3, which is 3 to this side, it should work for negative 3, which is 3 to that side, because when we go back to our x squared, negative 3 squared, 9, just like 3 squared was 9. And so by symmetry, we're going to get negative 3, 2.4, and negative 3, negative 2.4. So 3 and almost 2.5, and down here about 2.5. It's close enough. And then likewise by symmetry straight across on these ones. And again, these 4 points that I've just done were the points that we got from plugging in a particular x and then using our symmetry. And so here is the graph for this ellipse. And of course, 2 things to note. Number 1, I want to be able to see the 8 points, but number 2, I want to see the algebra that it took to get those 8 points. All right, now in number 12, we have the equation. Now, again, I have a positive y squared, a positive x squared. They have different numbers in front, so this will be an ellipse. But I'm going to need to do some completing the square to find its center, and then I want to find the foci, which will be along the major axis, and then find the eccentricity for it. So first off, we'll go ahead and rearrange things. We have 144x squared, subtract the 1728x, put in some space, then we'll have the plus 25y squared, subtract the 400y, some more space, and then the 3184 on the other side, so now it's negative 3184. Now, before we actually do complete the squares, we're going to factor out in each case. So here we're going to have 144 times, and then x squared subtract 12x. And let's go ahead and have our closing parentheses, and then plus, here we're going to take out the 25, y squared subtract 16y, and then again some more space, and then the negative 3184. And by doing this, it makes it easier to see, in fact, what it is we need to complete the square. So here we have half of 12 is 6, and then squared is plus 36. However, it's not 36 we're going to add to both sides. It's going to be 144 times 36, which is 5184. Over here, half of 16 is 8. 8 squared is 64. And this one is 25 times 64, so that's adding 1600. So now that'll give me 144 times x minus 6 squared plus 25 times y minus 8 squared equals, putting these two together, we're going to end up with 3600. Then we want to end up with a 1 over here, so we're going to take each one and divide by the 3600. So divide by 3600 here, here, and here. And so we'll end up with x minus 6 squared over 25 plus y subtract 8 squared over 144 equals 1. And from now putting it into the right form, we can say our center is 6, 8. Also, now that we have it in the right form, we recognize that a squared is 25, which means then that a is 5, b squared is 144, which means then that b is 12. So, this is a vertical ellipse because of the 144, so the major axis will be vertical, up and down. Now, in this particular case, c squared is going to be b squared minus a squared. Sometimes you'll see it as a squared minus b squared. The key is you have to pick the bigger one first so that you end up with a positive. So we're going to have 144 subtract 25, which gives me 119. So basically the c equals the square root of 119, which, if we were actually doing the graph, would be about 10.9. So both above and below the center, the 6, 8, we're going to have our foci. So our foci will be 6 and then the 8 plus or minus the 119, or, and this is okay too, 6 and then 8 plus or minus the 10.9 if we wanted to graph them. And of course there are two of them, so this would be 6 and then 8 plus square root of 119, and 6 and 8 subtract square root of 119. Or if you wanted to do it this way, 6 and 18.9, and 6, let's see, we're going to have 8 subtract 10.9, which will give us negative 2.9. And so those are our foci. I just did it both ways because we would turn them into decimals if we wanted to actually do a graph. Alright, so now we want the eccentricity. It is C, in this case, over B. The book tends to say C over A all the time, but then it switches A and B depending on which one is the major axis. I like always leaving the A's underneath the x squared and the B's underneath the y squared, and just changing the eccentricity equation just a bit. And so basically this is going to end up as 10.9 over 12. So the eccentricity is 0.9083, or we'll just round it 0.91. Since this is an ellipse, the eccentricity ends up being less than 1. If it had been a hyperbola, the eccentricity would have been greater than 1. And so there is problem 12. All right. Now we'll move into Chapter 7, where we had first sequences and series, and then we'll end up with some of our probability questions. So first off, expand and simplify. The sigma notation, the sigma is the thing that looks kind of like a capital E. It's a Greek letter. And so basically we're just, for wherever we have an I, we're going to plug in 1 through 5 and then simplify. So the expand part is plugging in all the numbers, and then the simplifying part afterward. So first off, we have 5 times 1 squared plus negative 1 to the 1. Let me go ahead and bracket. So that's the first one, this one, and in fact, maybe just to make it easier, there's our 1s there. And then the sigma stands for sum, so now we're going to add in the next one. 5 times 2 squared plus negative 1 to the 2. And so there's the second part of the sum, plus 5 times, next we'll have the 3. So here's our 3 and 3. And then the fourth one. So now we have 4 and 4. And then the last one, and so here we have 5 and 5. And so as you can see, we took the entire thing, and everywhere we had an I, we went 1, 2, 3, 4, and 5. So now that's the expansion part, and now the simplifying part. So we're going to have 5 times 1 plus negative 1 plus, here we got 5 times 4, so that's 20, plus here, negative 1 squared is just a 1, plus 5 times 9, that's 45, plus negative 1 cubed, so that's a negative 1, plus 5 times 16, that's 80, plus 1, because negative 1 to the 4th power turns it positive, and then finally plus 125, 5 times the 25, plus back to a negative 1. So these ones will all cancel each other out. And adding up the rest of it, I have 5 and 20, 25 and 45 is 70, and 80 is 150, and 125 is 275, so now I have 275, subtract 1, so my answer in this case was 274. Expanding and then simplifying. So one of those, seeing if you can do sigma notation. All right, next we'll have an arithmetic series type problem. Now it doesn't actually tell you that, so you know you've got to do a little bit of thinking about it to see, but I'm just telling you right now, this one will be arithmetic. And this is where we're going to have our 2 equations and 2 unknowns. So first off, A8, well that's got to be A1 plus 7D, and that's going to equal the 51. A3, on the other hand, will be A1 plus 2D, which is 16. Two equations, 2 unknowns, subtract, get rid of the A1s, we have 5D equals 35, which means that D equals 7. Now that I know that, I can come back into, say, the second equation, where I have A1 plus 2 times 7 has to equal 16, which means, of course, that A1 is going to be 2. 2 times 7 is 14. What plus 14 equals 16? A1 is 2. Now that I have both the D and the A1, I can go find A50. Again, the general form, A1 plus 1 less than the 50, so 49 times D. So 2 plus 49 times 7. My A50 is going to be 2 plus 343, which is 345. My S50, well, that's n over 2, which is going to be the 50, and then A1 plus A50. So again, that'll be my 50. So all these, this, and that all have to match. So the S50 will be 50 over 2, the 2 plus the 345, and my S50 comes out to be 8675. And so we have an example of an arithmetic. Next one is a geometric. And again, it's not going to explicitly tell you, but you can see that the denominators, I go from 5 to 25 to 125. So I'm basically just multiplying the denominators by 5 each time. It is an infinite series. You can tell that from this, because I'm not asking for any particular value like I did in the other one where I said A50 or S50 or something like that. So A1 is 1/5. R, well, you can take any two, and so for instance if I take this one, I do the 1 over 25 divided by 1 over 5. Because we don't divide by fractions, we multiply by the reciprocals, and I end up likewise with 1/5. It would not matter if I had taken the third one and divided by the second one. That would also given me the 1/5. That's the example of how I know it has to be a geometric series. Any two will have the same ratio. Alright, so in this case I'm going to use the equation I have for an infinite series. The key is r has to be less than 1. Since r is 1/5, we're less than 1. Or actually the absolute value of r has to be less than 1, but suffice it to say we're there. And so this is going to have 1/5 divided by 1 minus 1/5, which is 1/5 over 4/5, which gives us basically the sum is 1/4. And so now we have an example of doing an infinite series, an infinite geometric series. As mentioned before, this is an example of what the final will look like, just changing the numbers. So you will have one in which it's arithmetic, you will have one in which it's geometric series like this. So you'll be doing the same kind of problems. Alright, so now we're going to do binomial expansion to expand this. In other words, we want to use our pattern. There is an equation that goes with this that you're more than happy to use if you want to, but I can just follow the pattern. So let me show you here. We're going to have 5c0, 5 because the exponent was a 5, and then the first term 2x to the 5th, and the second term negative 3 to the 0. So that's my starting point. Okay, now next one, we're going to go 5c1, 2x to the 4th, negative 3 to the 1. So notice how I'm now going to progress 0, 1, then 2, and 3 up to 5. On the other hand, this one's going to go 5, then 4, then 3, and so forth, while the other one's 0, 1, 2. So follow the pattern. Like I said, there is a formula for it, but it's easier to just kind of remember that I'm going to count up and count down depending on the part I'm looking at. Notice that these always add up to 5 because I had n as 5, so 5 and 0, 4 and 1, 3 and 2. So next I have 5c3, 2x squared, negative 3 cubed, plus 5c4, 2x to the 1, negative 3 to the 4th, and then plus 5c5, 2x to the 0, negative 3 to the 5. So you can see how 5c0, 5c1, 5c2, 5c3, 5c4, 5c5. Now I'm not going to promise that the exponent will be 5, but whatever that one is, that's where you start. Something c0, and you're going to end up where the two are the same. Likewise, you take the first term, and it'll start with the same exponent, 5, and it'll go 5, 4, 3, 2, 1, 0, while the second term will go 0, 1, 2, 3, 4, 5 if you're going up to 5. Now, this is not the ending point. This is just the expansion following. This is just doing the binomial expansion, so it's similar to problem 13. Now that I've done it, I have to go ahead and simplify to see what the actual terms will be. And so first off, 5c1 is a 1, and then I'm going to have 2x to the 5th, which will be 32x to the 5th. Anything to the 0 power is a 1. Okay, next, 5c1, well, that's going to be a 5, because anytime you have a c1, it's whatever the first number is. And then I have 16x to the 4th and a negative 3. Then 5c2, which is 10. And then I have 8x cubed and a positive 9 to go next to that, because it's negative 3 squared. And then I have another 10. And now 4x squared and negative 27. And then 5c4, we're back to the 5. Anytime one is one less than the other, it'll end up with whatever the first one is. And so 2x and 81. And then the last one, back to a 1, 2x to the 0. And, well, that's just a 1 again. I should have just wrote this as 1. This is just a 1 because it's 0 power. And then the last part will be negative 243. And now all that's left is multiplying things together. So 1, 32 and 1, 32x to the 5th. Subtract, because I got a negative 3 here, so 5 times 16, that's 80. Times 3, negative 240, x to the 4th. And then we've got 10 times 8 times 9, so that's 720. Back to positive, x cubed. Now we're going to have our negative again. This one is going to be 1080 x squared, and then 810 x, and then at the end 1, 1, and 243, so minus 243. And so we have done the binomial expansion using our pattern as opposed to actually doing all of that foiling and so distributive property and so forth. Okay, problem 17. This is basically to use the NCR and NPR buttons, the key of which is NPR for order matters, NCR when it doesn't. So first, second, and third. So first, second, third order matters. We have 18 throwers. We want just the top 3, so that'd be 18P3. which using our calculator will be 4896. And I won't do it now, just to remind you, you will do this using the PRB button. There are three operations using the PRB button: NPR, NCR, and then of course just doing factorial. So that's the first one. How many ways can they finish first, second, or third? In the second one, notice that they are all in the top three, so we're not distinguishing between 1, 2, or 3. So top three, order doesn't matter. And so this is 18C3, and that comes out to be 816. Now, please note that it would be really easy to just go, well, hey, you know, one of them's 18P3, one of them's 18C3, go ahead and write them both down. But you are supposed to match which one goes with which. So the first, second, and third is the 18P3, the top three is the 18C3. So you just can't have the two answers there and like, well, you're supposed to know which one I mean. No, you have to actually say which one do you mean. All right, we've got one page left and then we'll be done. First, we're going to start off with a kind of basics of doing probability. We have a package of plain M&Ms, 3 orange, 7 yellows, 3 greens, 4 blues, 7 reds, and 11 browns. Okay, a whole bunch of them. And we want to know if A represents getting green M&Ms, find the probability of getting green M&Ms. So remember that in this case, probability is success divided by total. So, you know, really we want the green ones. Probability of getting a green one. Well, there's only 3 green ones. Okay? So that goes on top. Now, the bottom has to be the total. So we have 3 and 7, that's 10. And 13, 17, 24, and 11, that's 35. So we have 35 total M&Ms. So picking one M&M, your chances of getting a green one is 3 over 35. I tend to prefer decimals to 3 places, not counting the leading zeros. So I would prefer to have 0.0857, but I would accept 3 over 35 in this case. Now, that little line on top means not A, and since A is it's green, we want the P for not green. And we could do that the same way we did before. However, what we can simply say is it has to be the rest, the complement of what we've already found. That's what the not is for. And so we would have 1 minus the 0.0857, and that's going to be 0.9143. And so there's our answer for not picking a green one, over 91%. Now, by the way, if you're doing it in fractions, of course, it would be 1 minus 3 over 35, which is 32 over 35. And if you had counted all the ones that weren't green, 3 orange, 7 yellows, that's 10. 4 and 7, that's another 11. 10 and 11, 21. And then 11 more, 32 M&Ms that were not green. And so just some basics. Do you know what PA means? Do you know how to find P not A? And it'll be set up that way so that you could just go 1 subtract, and it's called the complement. You basically got to be green or not green in this case. You can't be both. All right, then we're going to come back to our polygraph table that you've seen before, in which we want to find first an OR case that has a both, and then an OR case that does not have a both. In other words, here's my OR, or here's my OR. These are the additive cases. that we're looking at, which means we add probabilities, and then if there's a both, we have to subtract. So one will have a both, the other one won't. So first off, probability of a positive test result, or they lied. So that's going to equal the probability of having a positive test result plus the probability that they lied, and then subtract the both case. In other words, they had a positive test and they lied. And if we check in our boxes over here, here's our positives, so there are 2 boxes. And here's our did lie, there are 2 boxes, but they both share that 370. We do not want to double count, and so that's why we have to subtract the both. So first, the p positives, the 130 and 370, that gives me 500 over 890, which is all 4 boxes added together. Then the p lied, the 370 and the 105, so that's 475, again over the 890. And then since both of those included the 370, we have to subtract it out so that we don't count it twice. And then we get 605 over 890, which is 68%. Now please note, I did mention this when we were going through this portion of the chapter. Note, none of these answers, here, 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 are over 1. You cannot be greater than 1. So if you somehow make a mistake and you end up with a number that's bigger here than down here, then that tells you you've left something out. I have to have a number that's less than 890 in terms of a probability. Now the second part here was find the probability there is a false positive or there is a false negative. So we want false positive or false negative. So false positive, and then add to that false negative. And in this case there is no both, because you can't be positive and negative at the same time. So first off, the false positive, note the box that says false positive, so that's 130 over 890. The false negative, there's the false negative box, 105 over 890, and so we get 235 over 890, or just over 26%. Again, you should never end up with an answer that's greater than 1. Alright, number 20 here. First off, we have a crate of 25 apples. You might remember something similar to this on the Chapter 7 test. Crate of 25 apples has 5 bad apples. What is the probability of selecting 3 apples in which there are 2 good apples and 1 bad apple? Okay, so this is more of the AND situation. Okay, we want 2 good and 1 bad. And so this is a multiply situation. Okay, so first off, the good ones, well, if I have 25 total and 5 are bad, then only 20 are good. Note that I've used the NCR type button here because I have 20 good ones to pick from. I'm going to pick 2 of them, but it doesn't matter the order, they're just good. And so it's 20C2 here. Now, I have 5 bad ones, of which I want to pick 1. And it doesn't matter which of the 5 I pick. So again, it's an NCR type. The 20C2, that's 190. The 5C1, that's 5. And so we end up with 950 ways. And really, I'm not really doing a probability there. A little bit of typo, it's probably on the test too, but this is all I wanted you to do. Really, if I'm doing probability, then note this is bigger than 1. It should be 950 divided by the total possibilities, which would have been I needed to take this and then go 25C5, because that's the total number of ways that I can pick 5 of them. And so I would need it to take the 950. And really what I wanted is just this. Not the probability, but just how many ways. So really I needed to divide by that as well, but I will just accept this for that. All right, and then finally, I don't think we had one of these on, maybe we did have one on the test, but this is a binomial true-false, just 2 possible answers. So the binomial equation, and again, you don't have to have any of your equations memorized. They are all there. You'll be given a page in which all the equations are given to you. You just have to know how to use them. So we have our NCR button again, because we're not concerned about the order. Probability of success on any one question. Probability of failure. So P and Q together have to add up to 1. This is how many we're going to have correct, and this is the rest of them, which will be wrong. So we want 6. So we're going to have 10C6, because again we have 10 question true-false quiz. We want to get 6 of them right, so these two have to match. True-false, so the chances of a question being right or wrong are 50-50. Again, we want 6 of them. Chances of getting it wrong, 50-50. And then there's 4 here. So note the 6 and the 4 have to add up to the 10. And so this is basically 210. 0.5 to the 6th power is 0.015625. And then 0.5 to the 4th power, 0.0625. Multiply that all together. 0.205. So not quite 21% chance of getting what 6 of them right. Not, please note, ABCD, not, or a true-false. You would think, oh, you know, I should have a chance of getting half of them right just by guessing, but no, it's down to 20%. And so there you have it, our test for the final. These are the questions you're going to get, just going to change the numbers, but you'll do basically the same thing on that.